Last week on the program, we saw the printed circuit board put together by some students undergoing internship program at the Hardware Development Laboratory, Physics Department, University of Lagos, Akoka, under the supervision of Dr. Henry Boyo. The students show more versatility this week with the processes involved in the construction of a zero-energy conservative building made from clay. What exactly is a zero-energy building? Young Inventors brings you answers in this educative episode. My name is Treasure Obasi, your host. This is Young Inventors, a production of the NTA Educational Television, where the promotion of learning is key. This week, we continue with another interesting innovation from the Department of Physics, University of Lagos. Supervised by Dr. Henry Boyo, the zero-energy conservative building located within the institution was constructed in a day, and it can be collapsed and reconstructed in a different location with ease.
You're watching Young Inventors.
A zero energy building is a building that runs on a self-dependent means of generating energy within, without dependence on grid energy, like supply energy from the PHCN, for instance.
Innovation will always drive technology.
These children you see here are the leaders of tomorrow. Therefore, we should support activities that will ensure in the next 10, 15, 20 years, these people become the leaders.
So I do commend you, NTA, for organizing this, and I'm sure you will keep the flag flying.
Get inspired. Get involved. Young Inventors, Mondays, 5:30 p.m. on NTA Network Service. Innovation, creativity, young inventors providing technological solutions.
The building is perfectly mobile. As we said earlier, it's not joined by any mortar. This is the quality of the zero energy building. It's completely mobile. The mobility means in the sense that in the future you might decide not to stay here again. Or you just need to set up another foundation well level, which is concrete, like we all know about foundation. After creating a leveling ground, then you can start the arrangement. You can dismantle it and relocate to the other side as you want.
This is a kind of modernized form of the old clay building, and you can see that the major concern to builder is at what compressive strength will the bricks fill. They are really load-bearing materials and they can withstand a lot of loads. If we take a look at this, for example, this structure, you'll see that an average block is supposed to weigh like 7 to 8 kg, except for the other blocks, which we call refractory. The refractory bricks have a mixture of sawdust, and this break down at about 45 kilonewtons. But the full clay blocks have a much higher compressive strength. If you look at this here that has failed, it failed not because it cannot withstand the strain, but because it is not well aligned. It's not sitting flat. It's not well seated on the one at the bottom. So it's now compresses in form of a cantilever shearing at the middle. But this does not mean that I cannot withstand that strain, because if you see the neighboring blocks beneath it and around it, and also carrying all this mass of load, have not failed.
Just like the printed circuit board, the construction of the zero-energy conservative building also involves several stages. The clay bricks are arranged in a way that each will interlock with another to form a pattern. It is a rigorous process, but the final product is worth the trouble.
This is the first stage in bricks production. This machine is called a mesh screen machine. It is used to separate the coarse particles of clay from the fine textured particles of clay.
The reason why we are doing this is so as to separate the fine particles away from the coarse particles. Because if we use the coarse particles in the production of mud, they'll create spaces inside the bricks, thereby making the bricks weak with all the spaces. But these fine particles, they will enter all the spaces, they'll fill it, and the bricks will be very, very strong when we produce it.
We can actually mold these bricks with clay alone, but in order to create stability, water resistivity, and strength, we are adding cement to it.
Cement adding enables them, as you said, the stability, the strength, and the water resistance. Some add water, as you said, it will be strong, but with strength, we add cement. Some add cement of 2%, varying on their need, some 5%. But we ensure strength, we are adding cement in the ratio of 10%.
Well, now we take it to the place we are going to mix it with cement.
Good mixing, too dry. Add the wet with water.
Actually, we are molding the bricks. So as you can see, we first of all started by lubricating the machine. This lubrication helps to reduce the friction, helping us to release the block so that there will be no kind of like shaking. So after that, we spray sawdust. We spray sawdust into the machine. Then we pour the paste. This is the paste. We pour it into the machine. So after that, we use our hand to compact the clay. After compacting, we cover and apply pressure. So this stroke, we uplift the bricks. This is in respect to one of the laws of physics, which says the Newton's law of motion, the third law of motion, which says action and reaction are equal and opposite. The downward stroke helps to release an upward force on this molder, so thereby pushing the bricks upward for us to easily remove the brick. So this is the brick which we just molded, and it will be taken over to the next section for curing and for quality control.
This is the part where we check the quality of each brick produced from the molding machine. We ensure that the brick is up to 7 to 8 kg. If it's not up to 7 kg or 8 kg, then it's not good to be used. This is weighing up to 7.6 kg, which shows that it is mature and it's ready to be used for any construction purpose. If it's not weighing up to that, then it's of no use because it's going to affect the quality of whatever is going to be used. The curing process is about wetting those ones there. We open the tarpaulin, we wet it every morning for 2 weeks. The curing is to ensure that the molecular structure of this brick is well fabricated. What are we saying in essence? By wetting this brick, because of the nature of the clay used in building this thing, it's hygroscopic in nature. which means it absorbs moisture. We wet them, and the wetting, after covering it, after wetting, we cover it. They are wetting it already. After wetting it, we cover it back. We wet every part of it to ensure it is soaked. This is what is called curing process. The curing process enables each molecular structure, each molecular component present in this brick to be properly locked together. So when we cover it back, we allow it for like 2 weeks. And every morning we repeat the same process. This same process, we repeat it every morning. And it slowly absorbs moisture, which slows down the drying process. Because if it's left to dry directly, it's going to be brittle, it's going to be squashable, it's going to be very soft, it won't be a correct building material. So this curing process enables it to be strong and durable for any structure that is going to be used for.
It does not depend on any external energy and can sustain itself without any power. The bricks have the property of locking out heat while the interior is cool, which means that no matter how hot the outside is, the interior remains cool. With this project, you don't need air conditioners.
This is the section where we check for the strength of the bricks. My colleague here, Shola, will be explaining to you on how to check for the strength of the bricks using the beaming testing machine.
But before we do the testing, we've already taken the measurement of the brick to check maybe it's a solid or a hollow brick. But after doing our calculation properly, we notice that the brick we have here is a solid brick because the hollow spacing is less than 25% of the whole volume. So now the next thing is that we are going to start feeding the bricks into the machine to check for the compressive force which they can withstand.
By turning on the machine, by turning on the pressure of the machine and applying force onto the brick to check for its strength, to determine if it's going to fail at a particular point or the other. And the machine is actually weighed in kilo by kilonewton per meter, as you can see. So now we're going to check for its failure. I need you to please help me with the results. For the first one, we have the first brick of 6.55 mass.
Okay. Kilogram. The first one, 6.55 kg.